Good morning. My name is Berta. This is Chris. I'm an iOS developer, and he's a designer at company Nebuda. And we do mobile apps. So one of the things that we do is that our teams are always interdisciplinary. That means we work really closely with developers and designers, especially when we do investigations with this thing on AR. So we're going to be taking turns through the talk. So first of all, what is augmented reality? So this is one of the biggest things that people have been saying on Twitter, other social medias, posts, AR, VR, but what it is actually. I want you to come out of this talk having an idea on how you can apply AR to your own apps. And for that, you need to know what AR really is and the types of different AR and how to do it. So virtual reality is when you are, like your entire reality is outside of your world. So if we were in this conference, it would not be here. We would be in the middle of a flower field. And augmented reality is when you actually augment this room that we have here. There is a mistake a lot of people do when doing use cases or trying to code for AR, which is they get into the middle of mixed reality. Mixed reality is very different from augmented reality in the sense that it doesn't augment the space that you are. It uses a space, but it changes it, and it barely uses it. So when you really want to do an augmented reality thing, or app or experience, make sure that the reality actually matters, that the space the user is going to be matters. Then there are different types of AR, and this is important because it's going to define how the user is going to interact with your app. And you can mix them. You can have an app that does a little bit of both, but it's better if you have a clear use case of what you want to do. The first one is marker and markerless-based AR. As you can see on the first example, that's the one with the dog. I use the frame that we have in an office as a marker. That would be a marker. You could use a QR code. You could use a badge from a conference. You could use any picture or object that you wanted as your marker for this to start the experience for the user. Markerless would be when the marker is not something that is physical, but it's part of the phone, like GPS or a light sensor, for example. When you are in an airport, you could start an AR experience, but it's still very much grounded for the user or where they are. Projection AR are types of AR experiences that you project a model, and the model interacts with their surroundings. So it would be like the example like Pokemon Go. The model is interacting with the reality. The Pokemon walks around. It goes over the seats or things like that. That would be an AR experience that interacts with the scene, but it doesn't matter where you take it. And superimposition AR, this is where the lines start getting a little bit blurred with mixed reality, but basically it augments the reality in the way that it changes it. So my example that I put was the face filter, because probably most of us have used at one time or another a face filter either from a Snapchat or Facebook. So those are the very biggest cases of superimposition. But it could be others. There was a game that I played that it basically turned your room into sort of like a horror game experience. That would be a very clear case of superimposition AR, where you're using your room and suddenly it's very dimmed and low and scary. So what can I build with AR? AR, as Jeremy said, has been going on for a very long time. But it's not a thing that was really available to use on users until phones catch up to it. Now we have almost everyone has a phone, and we can deliver those experiences to them. So AR terminologies of market and markerless, projection-based, type of virtual and mixed have been talked about and have been discussed a lot. This type of categories, I made them up. Those are mine. Use them at your discretion. I use them from a way of how to explain from a developer side. So this would be how the user interacts with your app. This would be how I think of an AR experience when I'm about to develop or think of them business-wise. The first one is a model-based AR. If you want your experience to just be the user interacts with this model of an IKEA furniture or an object or a really cool Pokemon, or in this case, the TARS that we built, then you use model-based. On the other, completely opposite hand, is functionality-based AR. That's when you extend a functionality you already have on your app, like Google Translate, for example, and you allow them to use it directly from the camera. So you give your users like a third-dimensional screen on where to actually use their where to actually get your data that you already have. So it has less design-wise things, less models, less complexity on the 3D wall, and more like a separate screen. And in the middle is business-based AR. That's where you're gonna kind of mix both. That's where you implement a functionality you already have, but giving the users a different way to use your app, and at the same time, use like really powerful models. Usually, those are the examples like this one, the Zara app or the IKEA app, made by companies who are actually like really betting on AR. So if you want to start testing on AR apps, I highly recommend you start by trying one of the sites, either a start by model or a start by functionality, and see how it feels, test it, and play with it. But if you're going to start with model, for example, which we did, you're going to have to learn how to design it. And that's where Chris is going to help.
Thanks. Hi, I'm Chris. I'm a designer. I usually wear glasses as well. So in order to start making AR experiences, we first have to get familiar with some 3D concepts. And those are not really hard to grasp. So instead of having our usual 2D canvases that we encounter in apps such as Sketch, Illustrator, Photoshop, our working environment now is a 3D room which is infinitely large. And in this room we can place 3D objects such as spheres, cubes, cones, you name it. And these shapes exist in that space just as pure geometry. They don't look like anything, they're just pure geometry. And this, by the way, is one of my favorite characters. It's called Tars from the movie Interstellar. He's going to help us with some slides. All right, so to start creating 3D models, we can use software such as Maya, Cinema 4D, and Blender. Blender is a good one to start with because it's free, so you can try your hand, see if you need some more advanced stuff, and move on to other programs such as Maya and Cinema 4D. For the purpose of this talk, we've used Cinema 4D for no other reason that a friend of mine was really good with it, so I could get some tips from him. But fundamentally, they all work the same, so you won't have any real difference there. All right, so before I said that the shapes that exist in that 3D environment don't really look like anything because they exist just as pure geometry. So how do we make them look like something? And there's three fundamental concepts to learn here. First of all, we have a material, and the material is what defines the look of an object or a surface. And this is sort of like layered on top of a surface or an object. And it depends on two things. A shader, which is a series of computations, basically, that determine the color of a rendered pixel, and the texture, which is usually just a bitmap that wraps around the surface. So say, for example, that you're creating a marble ball. The texture would be that unique marbly look, and the shader would be this glossy finish, almost mirror-like, and this would make up the material of the object, which would be a sphere in this case. As I was creating these slides, I came up with this metaphor to help me easily remember these things. So say that the objects that you have in the 3D environment is actually a human body. The material of the object would be the t-shirt that a human is wearing. The shader would be what that t-shirt is made of, such as wool or cotton or anything like that. And the texture would be the artwork that's on the t-shirt. So we cannot really teach you how to create 3D models in a 40-minute talk, but we can show you what happens after that point. So as you're preparing for export, there's about three things that you have to remember. And these are avoiding light sources, baking textures, and you might be thinking, what the hell does that mean? And anchoring properly. Now, avoiding light sources, as we're creating AR experiences, we have to think of the AR space as a real 3D environment. And in a real 3D environment, objects tend to get lit by external light sources, such as the sun or some sort of artificial indoor lighting. And that should be the same for 3D objects as well. 3D objects should be lit by this virtual light source in the scene, because objects don't carry a light source with them wherever they go. Except, of course, if you're making something like a lamp or anything that's self-lit, you have to remove all light sources from your 3D environment. And now back to baking textures. So what that means is that if you have a model that's got a lot of materials on it, baking a texture takes all of these properties of the shaders and the textures and hard codes them into one single bitmap file, which then wraps around the object that you're creating. And this is called otherwise a UVW map. And you can do this if you don't plan on taking care of textures and shaders natively within your rendering engine. And this will save you some precious processing power. A nice thing to have here is what's called ambient occlusion, and this is actually a setting that you can turn on when you're baking textures. What that means is that if you have some sort of global illumination in your scene, the object will cast shadows upon itself. And if you bake this into your texture, it will provide more of that feeling of realism. So it's just a nice thing to have. And that, by the way, is the baked texture of the TARS robot that you saw earlier. This is what it looks like. All right, and lastly, let's anchor our objects properly. When we were testing our AR app in the office, I would place some stuff on the pavement, and as I was moving around, the object wouldn't stay in its place. It was sort of like floating between the pavement. And I noticed that the problem with that is that I wasn't anchoring the object properly in the 3D working environment. What you have to do is set that anchor point exactly at the point where the object is supposed to touch the surface. And then you should set this object to the origin point of the 3D environment, which is to say the 0, 0, 0 point on the XYZ axis. And now you're ready to export. You can export in the OBJ object format, and this is sort of standard. ARKit and ARCore both support this. ARKit, the Apple one, also supports the DAE file format, otherwise the Collada 1.4 file format, and this supports some sort of rudimentary form of animations, but we won't get into that. Of course, you want to skip all that and get straight into the AR app. You can find some 3D models online, such as on Google Poly. It's got a nice library of free, rather cute 3D objects that you can download and use in your app. And also Google Blocks, which is a software that you can use to create your own 3D objects in VR space, VR. And also TurboSquid, which is a marketplace with very high-end 3D objects. Some are free, some are not, but it's definitely something to check out. Now let's fast forward to the point where we have created an app and we want to light the scene. There's a few points to remember here as well. You have to think of the AR environment as your real world. And in the real world, like I said before, there's usually one key light, and that can be the sun or the sum of artificial indoor lighting. And you should replicate this light source as a virtual thing on your AR space. A good thing to use here is the lighting estimation API. And what that does, it takes the intensity of the lights calculated from the camera feed, and you can use that intensity and set it on the virtual light that you have in your scene. And thus, all the object in the scene will be lit properly. Yeah, this is a nice example from Google. See how the lion instantly dims as soon as the lights are turned off in the room? This is using the lighting estimation API. All right. Do you see anything wrong with this picture? How many of you think this is manufactured? Show of hands. This picture is actually real. What's missing here is the shadows from the poles. This is actually a phenomenon that happens in Hawaii. It's called Lahaina noon, or something like that. Sorry if I butchered that. What happens here is that the rays of the sun are hitting the ground at an exactly 90-degree angle. So you don't see shadows below objects. And that makes it look like, it's almost like a bad render. It looks off, right? And that brings me to my next point. Oops. There. Shadows are super important in achieving realism. So in the first example, in the penguin on the left there, there's no shadow at all. I think you can see it here, yeah. And that makes it look like one of those poles in the previous picture. It looks like something that's on the screen rather than something in the real world. The next one has a hard shadow, and that's a good step towards realism. You might also see this called a ray-traced shadow. But usually, what you will see is that shadows are diffused, are more blurry around the edges, such as this third screenshot here. But if you want to go all the way and get as realistic as possible, you can use a diffused shadow with the shape of the object that's casting it, like right there. And now back to Berta with some tips on how to create AR apps.
Hi again. So as I mentioned before, I'm an iOS developer. So most of the code that I've made for actual AR apps and experiences is on iOS. But I've also worked with Unity and ARCore a little bit. So I'm going to try to be as less platform specific as possible and just tell you a little bit of what these SDKs can do, because they're actually quite powerful. And it's good to know what you can build before you start thinking of your experiences. So the first one is ARKit, as I mentioned. ARKit has a lot of similar things with ARCore, and they have the basic foundations that is the same. The basic foundations, I mean wall tracking, face tracking, rendering, a scene understanding, and environmental texture. On the right, I think it's on the right, yeah. On the right, you see the new things that ARKit 2 has, which is, image tracking, 3D object, gaze and tongue, and persistent and multi-user that are a bit different from ARCore. I'm going to explain a little bit those later on. And ARCore has the first things that are the same. It renders with a different framework, obviously. And it also has the light estimation, and it has cloud anchors, which is persistence, but in a different way from ARKit. And it has one thing that ARKit does not have, which is the ARCore SDK. You can use it to build on iOS, Unity, Java, and Unreal. So if you're choosing frameworks and you want to build for both, and you don't want to use Unity, it might be a better way to use ARCore, since you can build it on iOS, even though it has some limitations to it. But it's good to know. Now, wall tracking. So this is the main thing of what these SDKs and these apps do. Wall tracking basically means of how the phone can understand the wall around you. And it does this through tracking planes, so plane detection, which both ARKit and ARCore do horizontal and vertical planes. And it also does this by tracking those yellow dots that you see on the video. Those are called future points or hit points, depending on who you call. But they are basically edges using the change on lighting. And they are edges as you move. It's understanding the edges of different objects. These things get translated with all the information every frame that you move the app. Now, ARKit keeps a small world map. ARCore, even though it's younger, it has been built over a previous technology. So it's a bit more powerful in the way that the map that the app builds out of all this information going around is bigger. So if your room is bigger, ARCore might have a bit more stability on people just swiping really fast and the object being able to track that than ARKit. But Apple is probably going to catch up to this in a year or so. So for what we're doing, they are pretty much work on the same level of tracking. And the way they interact, the way you as a developer interact with this is via anchors. Anchors are one of the anchors are these points. They're basically three four-dimensional points on a space of where things are and how they are related to this wall. You can share those anchors on ARCore because there can be cloud, and on iOS you share the entire wall map with all the anchors. When you want to place an object, you place it in one of those anchors. You want to see if the user has interacted with an object, you basically translate the touch to an anchor in the scene. And all of this translation and placing, the SDKs actually do a lot of this work for you. They can translate 2D points into this wall if they can properly understand it. So the first thing is that all of the apps, all of the SDKs will let you know, so you can tell the user when the user has moved the phone enough that they have enough information to actually understand the wall. No AR experience can actually start until you get this wall figured out, in a way. Now, Unity uses its own engine for rendering, obviously, but it also uses ARKit and ARCore plugins. So everything that we've mentioned before gets on Unity, and it can build on both devices. But you have a bit less active to native tools in the sense that, for example, ARKit just started image recognition and object detection, which is pretty powerful on its configuration, but it's only for ARKit. So if you were building on Unity, you cannot use that for Android devices. So that has less access. Also, it's not in both ARKit and ARCore alone, standalone, you can use an AR experience inside of a previously built app. Unity, you build the entire app as an AR app. So that might make you more limitations unless you decide to build an entire AR app out of this, right? So yeah, so there are a little more things that you need to know when you design these things.
So these are some good practices on the UX side of things. First of all, teach your users to scan their environment. Like Berta said before, the AR framework has to create this virtual world through independent points that it scans. And to do that, the user has to scan the environment first. It doesn't work right away. So it's nice to have some sort of indication or tutorial for the user to know how to do this. I've seen a lot of apps that use some sort of animation of a phone, or actually a hand holding a phone and moving it around like that. It's good enough. And once some surfaces are recognized by the AR framework, it's nice to indicate these too. Most apps do this with dots scattered around the recognized surface. Next up, consider using drag interactions to add objects on your AR environment. A point and click is good enough, but if you have a drag interaction, you can drag the object and put it in AR space, and this gives you the ability to sort of indicate where exactly this object is going to be put in the AR environment and on which exact surface. And a nice thing to have is that if you have some sort of characters with limbs, you can make them sort of hold from your finger like that and dangle, and they can drop into the floor. This is a bit of an obvious one. Provide intuitive controls for lifting, rotating, and scaling if your app has to do that. A good thing to keep in mind is that no matter how far or near the camera feed a certain virtual object is, try to keep the touch target of that object the same physical size on the screen. Again, independent of how further or near it is from the camera. And lastly, maximize your 3D environment as much as you can. Users, when they use AR apps, usually tend to forget about the 2D UI on the screen. They even might fail to see it sometimes. So if you need to have some 2D controls on your screen, try to keep them for high-frequency actions and fast access. But even better, consider using volumetric UI, which is a fancy term for saying that instead of having 2D UI on your screen, try having these actions as real 3D objects inside the AR experience, making your app even more immersive. And now back to Berta with some closing statements.
So the technology part was quite quick because if it's not a specific to one framework, but there is more than just the tech. The SDKs do a lot of the things for you, and they're quite easy to use. The hardest thing is how you think of an AR experience. We are used at building, especially developers, collection views or lists or whatever that shows data in different shapes and views and animations. And we're so used to using that on our phones also, then a lot of the times we can pretty much do write code without having to run the app, and we know how it's going to look. We've been doing this for enough, we've seen apps enough. But AR is new, and AR does not work like that at all. So one of the first things that I would recommend if you want to do an AR experience is download as many AR apps as you can get your hands on. Start trying them. Start trying them on an environment like this one with really good lighting, then try them on an environment without lighting. Try them outside. Try them on a subway when you're moving on a moving car. Start getting comfortable with what an AR experience works like. Because if you're going to code one, you need to have an idea of what you're coding and how it's going to look. Then take inspiration from real-life situations. As I said, AR is about augmenting your reality. If you just want to drop a model onto a place because you think a Pokemon is cute, which I agree, but that's fine. But a good use case would be something that you go on the real life and you think, oh, I could actually do this better. Like you could actually start doing real life better, not only apps. And think and prototype on 3D and prototype early. We are not used at building these things, design or development-wise, and it's going to come out strangely different and with the funniest, non-really bugs, but bugs. Like one of the first things that we found was we were building this together, and he's in London, and I'm in Barcelona. And so we were doing pairing debugging on an AR app, which was interesting, but we couldn't find the model. And we didn't know it was because his model hadn't been properly translated, or I had done the code wrong. And we spent like an hour back and forth until we realized that our model, which was a house, was so big that we were inside of it, and we just couldn't see it. Right? We did, like, everything comes with centimeters and meters, and we look at this, and you look at this room and say, well, 1 meter should be good enough. But when you get to a phone, 1 meter is way too big for it, and you see nothing. You don't get these things until you start actually testing and early. You don't have that confidence of knowing these things until you get. So prototype in 3D and prototype early. Like, go out in the world and start trying this. And get constant feedback for people. Look at people on what they do. Give the phone to someone and look at what they do and why are they doing it. Because they're going to react differently to a 3D app or an AR app that they're going to do anything else. And you need to be ready for that. And take it out of the lab. I did, I think it was a workshop, and I didn't do this part. I didn't test it on new lighting, and it was a disaster. I had to like get lights from other places just to make it to work. So get it out, take it out, different lights, different scenarios, and just start getting into, because there are going to be a lot of bugs that are not really bugs on your code, and more just things that you haven't thought about, because it's quite recent new technology. But also use the SDKs things. They're really powerful, and you should always try to aspire. As a good friend of mine said, reality is the biggest view controller you'll ever work with. The AR is a new experience. It's a new way to get our users to interact with the apps that we have. It's a new way to like merge two different things that we usually do, our phones and reality. Use it, have fun with it. We had tons of fun with it. For a while, our offices looked like a madhouse of people just like going around with phones and laughing at each other. Have fun, play around, and just build AR things, because AR could be applied to like pretty much any app you can think of in a smaller degree or bigger, and you should. They are really powerful technologies, and I think they're going to be really interesting to look for in the future. Thank you.
Thank you.
Questions? Any questions? By the way, if you go to Noboda's blog or GitHub, there is a lot of the code and a bunch of blog series we did about this on ARKit, ARCore, and design part. So if you want more detailed tech information, you can go to both of those things. No questions?
Hello, thanks for the presentation. Can the light intensity API as well define the angle of the light?
It does in a way. Basically, what they do is that they translate everything, including what they define as light sources and the camera, as an AR anchor. so you can get those anchors and check if it's a plane, if it's a light source. But it's a bit tricky on the way that in very little cases, you will have only one light source. You usually have more than one. So both SDKs are actually really good with light estimation. The new ARKit 2, for example, it even allows you to, in reflective surfaces, it will reflect those objects. So if you put a model of something that has a metallic content, it will reflect the objects around it completely automatic for you. Because at the end of the day, their machine learning might be better than what you can come up with. It's Google and Apple, right? But yeah, you can. And you can get the planes, and you can get everything. The entire wall, you can send it to other users, and you can get all the information every frame. So every frame that you move, every time you move the phone, you get a new wall estimation. You can get all that information.
Hi. I have a question around, as a developer, how much of 3D geometry or understanding how 3D model works do I need to know? Or is it being taken care of by the ARKit itself?
Honestly, it's much better if you work with a designer because he left the models like anchored to the correct position with a good scaling. So it made my life infinitely easier. I tried for other things, I tried to like just download from TurboSquid, and I had a lot more problems. On iOS base, most of the issues is more knowing a SceneKit, the framework, which I haven't worked with a lot, so I had to learn that too, to understand what was happening, especially dealing with animations. It's the same for SimForm, so it's more knowing that framework, that 3D, but you do need to at least realize some of the basics for the beginning. Like you need always like 3D dimension to put things, and you need to like leave enough space between them, and objects have dimensions. I know it sounds silly to say objects have dimensions, but I forgot that for a second, and then a bounding box wasn't placing correctly because it's not center on the center. So I wasn't accounting for the fact that it has a width and a height. So you might have to tweak these things a little bit. If you want to get more into like having each one of the objects move and react with each other, then yes, you're going to have to deal with gravity and physics. But it's mostly things that if you've coded for video games before, using a SceneKit or Unity, it's information you already have.
Got it. I've been always afraid of like 3D matrix multiplication and other things, so that's what has kept me away from AR.
They do a lot of these things. Both ARKit and ARCore have a translation of their like what they understand to like 3-vector objects that automatically goes for position of 3D SceneKits. So a lot of this work is done by you. With everything, if you want to do something very specific that they didn't account for, then you might have to go low level and like but for starting to create just a good example or even like a demo prototype, you shouldn't have to have a lot of problems.
Perfect, thank you.